All right, we're looking at trigonometric ratios today, or simply just trig. We'll say trig ratios, basically is what we'll say. But trig ratios deal with a right triangle. This is a right triangle. We know it's a right triangle because right here is my right angle. Okay? Now, when you have a right triangle, the three sides have certain names. The two sides that form this right angle are called legs. This is a leg, this is a leg. We have two legs that form this right angle. The other side that does not touch the right angle is called the hypotenuse. So we have two legs, we have a hypotenuse. The hypotenuse is always the biggest side of the two triangles. The two legs are the smaller two sides, and like I said, they always form the right angle. And right here we have this angle, and we see this little Greek character in here. This is called theta, T-H-E-T-A. And we'll use theta a lot for our angles in a triangle. But this is the main thing. These two angles right here, this one's not labeled. Sometimes we might call it a beta, like have a funny looking B, beta. But these two angles are acute angles. They're less than 90, and this angle is 90. Your total triangle has 180 degrees. And since this one's 90, if you do 180 minus 90, that means that these two angles here have to add up to 90. So they're both acute. They have to be less than 90. There's no way they can be over 90. All right, well, in trig, we have these special ratios. And so we have sine, cosine, and tangent. These are our ratios. Sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. Now what that means is, we'll go back to this picture here. So if we're looking at theta here, this angle, okay, we have two legs, and then this leg right here, the A, is what we call the adjacent leg because it's right next to our angle. See, here's my angle theta, and this leg is touching that angle. It's right next to it. This leg over here, however, is away from it. So we call that the opposite leg. We have an adjacent leg and we have an opposite leg every time. So sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. Then we have tangent. Tangent is the opposite leg over the adjacent leg. Or we'll just say opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. We won't say the legs. Now, this is a way you can remember it right here. This is what I always use. Some old horse caught another horse taking oats away. Which this means some old horse, using these first letters, caught another horse taking oats away. And that helps you remember the first letters in these. Now there's several different ones that you can, and you can even make up your own to remember these. I've heard this before. Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. There's all kinds of them on the internet you could look up, or you can make up your own to remember these. But these are vital that you know the ratios here for sine, cosine, and tangent. Okay? So now what that means is, like here's a triangle. We should be able to figure out what the sine, cosine, and tangent is of an angle in a triangle. So like right here, here's angle alpha. This is an alpha. Okay. What's the sine of alpha? Okay, well first let's label our sides. So since we're dealing with alpha here, this B here is my adjacent leg. This is adjacent because it's right next to alpha. Okay, which means this leg over here is opposite. That's the opposite leg. Clearly C right here is the hypotenuse because it does not touch the right angle. So here's my three sides labeled. And so if I want the sine of angle A, I just have to go back to these right here. Sine is the opposite over the hypotenuse. So that's going to be A over C. This is A over C. What's the cosine of A? All right, the cosine, if you go back to your cosine is adjacent over hypotenuse, which that's going to be B adjacent over hypotenuse, B over C. And of course, tangent is opposite over adjacent, which is going to be the opposite A over adjacent B, so it's going to be A over B. Okay? Now, suppose you switch to angle beta. What's sine of beta? All right, well, that changes things now. Now, this is still the hypotenuse here, but this A right here is the adjacent now for beta, and this B over here is opposite of beta. All right, so we have to change our names for that one. So now, what's sine of beta? Sine is opposite over hypotenuse, so it's going to be opposite B over C. This is B over C. Cosine of beta is going to be adjacent over hypotenuse, so it's going to be A over C. And then tangent is going to be opposite over adjacent, which would be B over A. All right, so that's how you find the trig ratios. All right, here's another one here. Okay, we've got this triangle here, triangle CAT, cat. All right, what is sine of C? All right, here's C, angle C up here. Well, we've got to label our sides. So automatically, this is the hypotenuse over here. See, there's the right angle. The hypotenuse does not touch the angle, so that's a hypotenuse. These are my two legs. The two legs form the right angle. Two legs form this right angle. So if that's my angle I'm dealing with here, this 7 is my adjacent because it's right next to it. This one is away from it, which is the opposite. Okay, so in sine of C, sine is opposite over hypotenuse, so it's going to be 24 over 25. You really don't need a calculator for this at all, just getting this trig ratios set up. Cosine of C is adjacent over hypotenuse, 7 over 25. And then tangent of C is the opposite over the adjacent, so it's going to be the opposite over adjacent, 24 over 7. Okay. Now over here we're doing T, which is this angle. Okay. So now we're doing this angle, which means my stuff changes. Now this is still hypotenuse, that's okay. It's always a hypotenuse, but the legs is what changes. So like this is no longer opposite. This is adjacent now for this angle, for angle T. And this would be opposite for angle T over here. See, that's away from it. So for angle T, this is opposite. This is adjacent. So now if I do sine, sine is opposite over hypotenuse. That's going to be 7 over 25. Cosine of T, cosine is adjacent over hypotenuse. So it's going to be a 24 over 25. Then tangent of T, this is opposite over adjacent. So it's going to be opposite, which is 7 over adjacent, 24. Okay. All right, so let's look at some of these here. We got just a problem asking for one thing. This is asking for tangent of theta. All right, now remember, tangent is the opposite over adjacent. Okay, so for this one, tan theta, we've got to label our sides. So here's my right angle, so that makes this the hypotenuse over here. And over here, this would be opposite, and here would be adjacent. Okay, so the tangent is the opposite over adjacent. Well, we don't know the adjacent here. So we know it's 12 over something, and it looks like 12 over 13 probably. But no, I don't think that's right, because that's the hypotenuse. 13 is the hypotenuse. So really, you can't guess on it. You can't say it's that one. What you're going to have to do is you're going to do the Pythagorean theorem. A squared plus B squared equals C squared. where these are your legs, and this is your hypotenuse. So your hypotenuse is 13. That goes over here. Okay. Now, your A and B are these two here. We don't know this one, so we'll just put an X for that one. This is 12, so we'll put 12 squared there. Okay, so we're going to solve this. So I'll minus the 12 squared, which means x squared equals 13 squared minus 12 squared. And now I can just punch that in. So let me get my calculator here. 13 squared minus 12 squared. It's easier just to type it all at one time. So I got 25. So it means x squared is 25. So now do the square root. The square root of 25 is 5. So there you go. My adjacent up here is 5. Okay. So tan, oh, I'm messing up anyway. So here's my theta down here. I was thinking that was theta right there, so it was right at the corner of this. Here's my theta down here. All right, so the opposite, I got them labeled wrong now. So this is opposite over here, and this is adjacent. I just now realized that. There's my theta right there. I thought my theta was this right here. I wasn't paying attention. All right, so tangent is going to be the opposite, which is 5, over the adjacent, which is 12. So this is 5 over 12. Okay. Now, I think in each of these, we have to find the missing side. So like right here, this is 5, this is 12. These are my legs. So a squared plus b squared equals c squared. So this is going to be 5 squared plus 12 squared equals c squared. And I can just type that in. 5 squared plus 12 squared. That comes up to 169. So I do the square root of that answer, and I get 13. So this is 13 right here. Okay, so I do 5 squared plus 12 squared, which is 169, and then I square root both sides, which is 13. Okay, so now there's all my sides. So let's label them. All right, so here's my theta right here. We're not making that mistake. It's right there. So this will be my adjacent leg right here, and this is my opposite leg over here. This is the hypotenuse. Sometimes I go ahead and do the hypotenuse first because here's the right angle, and I know the side that does not touch the right angle is the hypotenuse. All right, so there they are labeled. All right, now what's the cosine of theta? And if you remember from earlier now, cosine is adjacent over hypotenuse. You got to remember those. So cosine is adjacent over hypotenuse. All right, so my adjacent here is 5, and my hypotenuse is 13. This would be 5 over 13. Okay. Now, number 3. All right, we've got, this is my right angle, which makes this my hypotenuse up here. And here's my 2 legs. Well, I don't know this one here. It's missing, so I'm going to do a squared plus b squared equals c squared. And so my 2 legs are 15 and x. So x squared plus 15 squared equals my hypotenuse squared. So let's just minus the 15 squared. And I can do this now. So I punch that in. 17 squared minus 15 squared. And look there, I get 64. So I square root now, and the square root of 64 is 8. So x would be 8. So this right here is 8. So you got to do the Pythagorean theorem to figure out the missing side of the triangle. Now it's simple. Here's my theta. We're looking for tan theta, which, if you remember now, tan is opposite over adjacent. Tan is opposite over adjacent. So tan is opposite over adjacent. So let's see here. Let's label them. This would be my opposite right here. This is adjacent right here. See, adjacent's right next to the angle, whereas the opposite's away from it. So this is going to be the opposite, 8 over 15, right there. Okay. What about this one now? All right, so we've got missing side here. So a squared plus b squared equals c squared. So my two legs are these two. I don't know this one, so x squared plus 3 squared equals 5 squared. So I minus 3 squared. X squared equals, all right, I can do that now. 5 squared minus 3 squared. 5 squared minus 3 squared. That's 16. So now I can square root both sides, and there you go, x is 4. Square root of 16 is 4. So this missing side is 4. Okay, now let's label them. All right, so here's my angle, which down here, this is the hypotenuse. Okay, automatic. There's the right angle, there's the hypotenuse down there. And then this one is next to it, that's the adjacent, whereas here's the opposite over here. Okay, so we want sine. All right, sine is opposite over hypotenuse. So we want the opposite, which is 4, over the hypotenuse, 5. 4 over 5, right there, A. Okay, number 5, we'll do a couple more. All right, we got this missing side, and I think we just have one like this. Yeah, right here, see, 5, 12, and 13. 5, 12, and 13. So this is 5, 12, and 13 also. Okay, so we cheated a little bit there. But, again, we do a squared plus b squared equals c squared. And I've got the hypotenuse here, and I've got this leg. So x squared plus 5 squared equals 13 squared. So I minus 5 squared. X squared equals 13 squared minus 5 squared, which comes out to be 144, and then I square root it. So x would be 12. So we got that. All right, now label the sides. Well, here's my hypotenuse. There's the right angle, so there's my hypotenuse. Now here's the angle I'm dealing with, my theta. So this 12 is adjacent, right next to it. And this is away from it, so that's the opposite. All right, now sine is opposite over hypotenuse. So it's going to be 5 over 13. So there you go. Okay. All right, we'll do number 6 here. All right. So we got 20, we got 25, we got this missing side. So a squared plus b squared equals c squared. And if you look, notice this is my hypotenuse right to here. So this is the c. So I got x squared plus 20 squared, and so I'm going to minus 20 squared. So x squared equals 25 squared minus 20 squared. So let's punch that in there. 25 squared minus 20 squared. That's 225. Oops. So I square root both sides, which means x equals, that's 15. Square root of 225 is 15. So this missing side over here is 15. All right, now we've already said this is a hypotenuse. These two are my legs. So here's my theta, which means this one is next to it, is adjacent, and this is away from it. This is opposite. So there they are labeled. Okay, now we're looking for cosine. If you remember now, cosine is adjacent over hypotenuse. So this is going to be adjacent, 15, over the hypotenuse, 25. So it's 15 over 25, and that simplifies 3 over 5. There's the answer. Okay, so this is how we do trig ratios. If you need some help with it, let me know. I'll try to help you all I can. That's it for today, so have a good rest of the day. Bye-bye.